We just finished hearing that video about the limits. So the limit is the intended height of a function whether or not it actually reaches it. So that's kind of huge for you to think about, that it's not really there, but it's intending to get there. So when I ask what a limit is, you got to think through, well, even there's a hole there, there's really, I'm intending to try to go there. So a limit of a function for some x value a is the height the function gets closer and closer to as x gets closer and closer to a from the left and the right, but not actually at the actual point a. So here's kind of the verbiage or the math kind of equation of what we're talking about. The limit as x gets closer and closer to a from both the left and the right of some function is equal to L, or the limit of f of x as x approaches a. So when asked to find the limit of a function as x approaches a given value, we're really trying to find what? The x value or the y value? The y value. The height, right? So just think, equate limits to height. Limits to height, right? Okay, so this might be a little complicated for you to remember, but let's just see. Who can tell me what f of negative 2 is? 0. Very good. Does everybody see? At negative 2, when x is negative 2, negative 2 goes into the function machine. What comes back out? The y value, right? The output, the 0. Yes? What about f of 0? So when x is 0, we have a hole here and something, it doesn't even go where x is. So this would be undefined. We don't know what it is, right? Okay. How about the next one? F of negative 1. Oh, you might think there's 2 points there. It's 3. It's a hole here, so negative 1, x value for negative 1 isn't there. It's there, right? 3? Okay, how about f of 1? Does everybody see it's 2? Okay, so do you know how to read these functions now here? Okay, so now we're going to go to limits. So now this is the intended height, but it doesn't actually have to go there. Do you know what I'm saying? So let's look at x goes to 2. What is the intended height when x comes closer and closer and closer to 2 from left and the right? Yeah, I don't know if a 3.5. 3.4? 3.3? Yeah. I'll say roughly 3.4, say, yep. I don't know why I had that one, but anyways. How about f? The limit as x goes to negative 2. It is 0. It is 0. What about when it goes to 1?
1?
It is 1 this time. So even though the value at x equals 1 is 2, the function intends from the left and the right, it really wants to go to the height of 1. It doesn't get there, but it really wants to go there. That's what limits are, okay? This is kind of mind-blowing now because it's kind of like, whoa, I thought, But yeah, it's what it intends to go to, not actually necessarily getting there, okay? How about this one? Negative 1. Well, if it doesn't say if it's coming from the left or the right, then it's coming from both sides. So you can't. So you got to ask yourself, if it's coming from the left or the right, can you make a decision of where it's intending to go? No, it's not somewhere in between. You can't. You can't make the decision. Like here, when it's coming from the left and the right, it's pretty obvious it's coming to this height. But here, when it's coming from the left and the right, one goes to here and the other one goes to here, so you don't know. So this is where it is. Does not exist, which is different than undefined. Undefined is an actual point is undefined, but the limit is going to be does not exist. Okay, so moving on. We have what's called left side and right side limits. And when something's a left-sided limit, would mean it's coming from the left, you'll see that x approaches a and then it has a little superscript with a negative there. That means it's coming from the left-hand side. So it is the left limit of f of x as x approaches a from the left. I.e., we only consider x, if it's on the left of a, it would be less than a, right? And then I guess yours goes on the next page here. So the right-handed limits are the limits that are coming only on the right-hand side. And so it's denoted with a plus superscript here. So that means it's only coming from the right. So if you look above, it didn't have a sign as a superscript. That means it was coming from both sides. When it has a little sign, that means it's only coming from one side. Okay? So x going to a with the superscript plus means it's the right limit when x approaches a from the right. We only consider x greater than a. Okay, so if I go back to this diagram and I said it's coming from the right, it's coming from this side going this way, right? If it's coming from left, it's coming this way, right? Yeah? Okay. So, for it to come from both sides, and you get this limit, say, it could be 5, it could be 10, whatever the limit is, the height. This is only works, as we saw, if they both equal the same thing. Meaning, if it comes to the left and it goes to 5, and it comes from the right and it goes to 5, then the limit is 5. But if one side comes to 5 and the other comes to 10, then that's when it doesn't exist, right? Okay, so let's look at this graph now. Should I give you a moment to see if you can answer it? Or do you want to do it together? Together. Okay. Okay, now, if I say f of negative 3, that means I want an actual point, right? So if the input is negative 3 in this function, what would the output be? Huh? Well, it's an asymptote, so what would that mean? So if it's no value, then undefined, right? Okay, let's go to B. How about the limit as x goes to negative 3, and what's that sign? A minus, so it means it's coming from the left. So we're following the function from the left. Where does it go when it gets to the 3? What's that? Negative what? Negative infinity. Negative infinity. How about when it comes to negative 3 on the right? So it's following the function, and it's following, and then all of a sudden it goes. It's going to positive infinity. Does everybody see that? Do you want me to just trace it again? Or you see that it's going to positive infinity? Okay. So how about D? What does that mean? It's coming from both sides. Do we know? If one's going to positive infinity, one's going to negative infinity, they're not going to the same place, so does not exist. Hey, you guys are catching on. Yay. Okay, how about f of 0? Negative 2, yeah. Okay. The limit as x goes to 0 from the left. What is the intended height when you follow the function to 0 from the left? It's 0. Does everybody see? It wants to go to 0 from the left. Do you see how you're following this? It wants to go to 0. Okay, the next one is it wants to go to 0 from the right now. So follow it from the right. Where does it want to go? Huh? -2, yes, exactly, -2. Come from the right, follow it. It wants to go to -2 when it gets closer and closer. Yep. Okay. So now I put it all together. On the left, it wants to go to 0. On the right, it wants to come to -2. So from both sides, what's the intended height? We don't know. So what does that mean? Does not exist. Okay. We getting this? All right. F of 3. Does everybody see it's 3? F of 3 is 3? You guys are good. Okay. X goes to 3 from the left. Where does it want to go? 1? How about from the right? 1. So, from the left it wants to go to 1, and the right it wants to go 1. So really, where does it want to go? 1. Do you see how this works? If you know it's coming to the 1 and from the left and the right, then you know the limit together wants to go to 1, even though the value at f of 3 is 3. This has nothing to do with the limit. It's where the function intends to go. Okay, this might be a confusing one for some. What does this mean? The limit as x goes to infinity. I kind of threw that in last year, I think. Yeah, when x gets to the far right as possible, if you could continue this graph as far right as possible, what is the intended height of the function? I'm sorry? It keeps going down, yeah. So what is that? -infinity. Very good. Does everyone understand that? Like, this is an arrow here. It keeps on going and going and going and going. Like, so if I get to some abnormal huge number, it's going to be abnormally negative, right? Okay. So what does this mean? The limit as x goes to -infinity. That's the far left this time. So if I continue this graph forever and ever to the far left, what's the intended height? 0. It really wants to go to 0, doesn't it? It doesn't get there, but it's trying. Exactly. That's what you have to kind of get through your head for limits. It's what it intends to go, it really wants to do, but it might not do it, right? It's kind of you putting off your chores. You really want to, but something else is more exciting, so you do something else. Okay. Infinite limits. When x goes to a of f of x equals infinity means that the values of f of x can be made arbitrarily. The values of f of x can be made arbitrarily large, positive. I guess the biggest thing you have to get out of this is that infinity is not an actual number, right? It's a concept that means, like positive infinity means it's very large positive numbers, right? Okay, and so then negative infinity, what does that mean? It's arbitrarily, you might say small, but it's not actually small. It's actually big negatives. Like, if you think about that for a second, it's really big negatives, right? It's large negatives. Does that make sense to you? I know you think that you're going that way. It's small. It's small in, I guess, in positive terms, I guess. But if you think about in negative terms, it's really large negative numbers, right? So in either case, the line x equals a is a vertical asymptote. And we know that from grade 12 pre-cal. When you have a graph here and you have a vertical asymptote, you might be going, you know, say all the way up there, or you could be going all the way down there, right? Yes? but you have an asymptote there. So anyways, I guess I have an orange textbook here, but really you only have a green textbook, so that's all I got there. Where did my thing go though?